All right, today we're going to dive into the art of building software that is truly, deeply reliable. We're going to look at a project called Waveform Core, and its almost obsessive quest for something called deterministic analysis.
So, let's just start with a question that probably hits a little too close to home for anyone who works with data. You ever run a really complex calculation, you get a result, and then you run the exact same thing again, and the answer is just different? It's infuriating, right? And it completely shatters your trust in your own tools.
You know, this isn't just some small annoyance. For scientific computing, it's a catastrophic flaw. It's the ghost in the machine. And the project we're exploring today, Waveform Core, was literally built from the ground up to exorcise that ghost, for good.
So how in the world do they pull this off? Well, it all starts with a core philosophy, something the project calls the observer's doctrine. And it's all about a radical, almost fanatical commitment to not interfering.
Here's the central idea, and it's a powerful one. You have to think of Waveform Core not as some kind of engine that does things, but as a scientific instrument, like a perfect microscope. Its one and only job is to observe and report on reality with absolute fidelity, without ever changing the thing it's looking at.
And they draw a really hard line in the sand here. The project calls this projection-only tooling. So sure, it can look at anything. It can read traces, analyze signals, you name it. But what it can never do is touch anything. It's forbidden from influencing the runtime or messing with external files. Just think of it like this. Truth flows in and reports flow out. That's it. Nothing ever flows back. And this quote, man, it just says it all, doesn't it? I observe universes. I do not run them. That's not just some clever tagline. That's the project's entire reason for being right there.
Okay, so building on that philosophy, we get to the project's central technical promise: absolute, uncompromising determinism.
And when they say determinism, they mean it in the strictest way you can possibly imagine. We're not just talking about getting the same final number at the end. Oh no. It means everything has to be identical. The exact same data pairs, in the exact same order, with the exact same stats. Every single bit of the output has to be the same, every single time. So how do they actually keep that promise? Well, they systematically hunt down and eliminate every common source of randomness. There are absolutely no hidden random number generators, no code that depends on the time of day, no writing to the disk, and this one is critical, no funky parallel processing tricks that could reorder calculations and introduce those tiny, maddening floating point differences. And this commitment goes incredibly deep. I mean, look at this. Even when sorting data where two things might seem totally identical, there's a three-level tie-breaking system in place. First, it sorts by birth time, then by dimension, and finally by a lexicographic sort, which is really just a fancy way of saying putting the raw data in alphabetical order. There is zero room left for ambiguity. None.
And all this internal discipline, it isn't just for them. It's actually exposed to you, the user, as a kind of public contract, a set of guarantees that you can literally build your own work on top of.
Just take a look at the command line interface. The philosophy here is straight out of the classic Unix playbook. It does one thing and one thing only. It reads your input, it emits the truth, and it exits. That's it. No weird side effects, no network access, no writing files where you don't expect them. It's a pure, self-contained instrument for analysis.
But this is where they really put their money where their mouth is. How do you enforce this promise over time? Check this out. You can add new features, you can fix bugs, and that's just a minor version bump. But if you change the numeric output, even by the tiniest fraction of a percent, that forces a major version update. And for anyone who works in software, you know that is a massive commitment to reproducibility. So finally, let's pull back the curtain and see how the project makes sure all these principles actually hold up before a single line of code ever sees the light of day. This is what they call their definition of done.
So how do they guarantee all this stuff? Well, it all comes down to this number, 7. 7 core pillars.
And these 7 pillars of release readiness, they're not just some vague hopes on a whiteboard. Nope. They are a hard, non-negotiable checklist. If even one of these isn't satisfied, there's no release. End of story. So pillar number 1 is correctness. This means it has to pass a whole battery of rigorous mathematical tests, and it has to produce known, stable results on a suite of golden reference datasets.
Pillar 2? Well, that's that core promise we've been talking about, determinism. See, it's not just a goal, it's a test that absolutely must be passed before any release can happen. Pillar 3 is all about creating stability for other developers. The public API is kept as small and stable as possible, so if you use it as a library, you can trust that an update isn't going to suddenly break all your code.
And the rigor doesn't stop there. It just keeps going across 4 more pillars, covering everything from the command line interface to the documentation to performance, and of course, maintaining that all-important observer's doctrine.
And this quote, it really just captures the whole goal. In a software world that's constantly chasing the next big, flashy feature, Waveform Core's entire ambition is to be something much, much rarer, boringly reliable. And you know what? There's a real beauty in that. Which kind of leaves us with one last question to chew on. In a world that prizes novelty and moves at a breakneck pace, what is the real power of being perfectly predictable? What's the true value of creating something that you can trust absolutely and completely?